This is page 221, number 29. Okay, we're looking at number 29. And in 29, they give us a whole lot of information, including the relationship between R, R1, and R2. So since we have that relationship, let's go ahead and take the derivative. But first, I think I want to rewrite this with negative exponents. This is R1 to the negative 1, R2 to the negative 1. So the derivative will be negative R to the negative 2 dr dt equals negative R1 to the negative 2 dr1 dt plus negative R to the negative R2 to the negative 2 dr2 dt. And I'm going to rewrite this once again. This is negative 1 over r squared, negative 1 over r1 squared, 1 over r2 squared. And now let's fill in the values that we know. We're looking for dr dt. We know that this is negative 1, and R1, they tell us, is 30. So we've got a 30 squared over here. And the rate of change of R1 is 0.01. Since I'm working with fractions here, I'm going to change that to 1/100th minus 1 over R2 we know is 90 squared. And the rate of change of R2 is 2/100ths. And the only thing that we're missing at this point is the value of R. So this is negative 1 over R squared. And we can find that using the equation that they gave us. We know that 1 over R is equal to 1 over 30 plus 1 over 90. Which means that 1 over r is equal to 4 over 90. Let's simplify that. 1 over r is equal to 2 over 45, which means that r is equal to 45 over 2. So r is 45 over 2, and we are squaring that. So dr dt is equal to, I'm going to move that fraction to the other side, so this is going to be negative 49 over 2 squared, but times negative 1 over 130 squared minus 2 over 190 squared. And at this point, I am taking out my calculator, and I am getting so we have the rate of change of R with respect to t is 0.006875 ohms per second.